Hey there, in this video we will try to solve LeetCode question number 3 and 7 contains duplicate. So here given an integer array nums, we're gonna have to return true if any value within the array appears at least twice, and return false if every value is distinct. That means there isn't any duplication of values. So I will show you how to solve this problem in 3 ways. So the first gonna be the or solution, and the second be maybe will be the sub optimal, and the last will be the most optimal solution. So let's go through the examples to better understand the question. So here we have a nums integer array, and here we have 1, 2, 3, and 1. So here we can see that 1 is repeated 2 times. So here we're gonna have to return true as per the question. So so here we can see in the output it's returning true. If we take a look at the second example, here we can see that in the input it's 1, 2, 3, and 4. So here there isn't any duplicate value, so it's returning just false. Third, we can see that in the integer array there are 1, 1, 1, and then 3, 3. So if we can check the array full, we can see that there are more than one duplications. So we have nothing to do with it. As per the rule, we just have to check if there is at least twice a value in the array. We're gonna have to return true. So it's returned true because there are a value that is there at least twice. So now let's check how we can solve the problem. So at first, what we can do is the OR solution, or the non-optimal solution would be to just create 2 for loops and iterate through each of the array n times. So here, if I iterate through the 1, if I check for 1, we're gonna have to check if 1 matches with the next value of 1. If not, we're gonna have to check for the next, and then if not, again we're gonna have to check for the next. In this way, we're gonna have to iterate for the array once only for the first value. So it's gonna be O of n only for checking the first value. For the second, it's gonna be again O of n. For the third, it's gonna be again O of n. So it will be a result of O of n square and complexity. So let me put it down over here. O of n square, and the space complexity will be O of 1, because we are not using any extra memory, or not just using any hash map or something to store the values. So this is not a really good solution, to be honest, because we are in a quadratic mode, and the space is though in a constant, but still O of n square isn't a really great solution. It's gonna just take a lot of time for if the number of inputs is much bigger. But still, let's code it up. So if you can see over here, we have the nums integer array. So as mentioned over here, we're gonna have to iterate through the array n times. For 1, we're gonna have to check it thrice with 3 values. For 2, we're gonna have to check for 2 values, this and this. For 3, only once. So for implementing this in the code, we're gonna have to use nested for loops. So let's write for okay, before that, let's declare a variable that will contain the length of the array. Now we can write like for I in range, and use the n. And as we are declaring the n to be the length of the nums array. So for I in range, the n, then we can set up another for loop for j in range. It should be I plus 1 comma n. So here the first value that it's gonna iterate is I plus 1, because if you can see I, this is the I, so plus 1 should be 2. So we need to compare 1 with 2. We don't need to compare 1 with 1. We need to compare 1 with 2. So we are using I plus 1. And the last value should be n. And then we can set up a loop like if nums I matches with the um, nums of j index, then we can just simply return true. But if it does not, if it does not means if in these for loops we don't find any duplicate values, we can just return it to be false. I believe it should do. Let's try to run the code before submitting it. Oh, sorry, I think I missed the code on over here. Okay. Okay. Okay, so I was just miscalculating the indentation point. So here we can see for the case 1, it just run without any issues. For the case 2, it just run without any issues, and the case for 3 as well. So here it's not a really great solution. As I mentioned, O of n square is not a really optimal one. So now the question is, how can we make it a little bit better? So this was solution 1. Now let's check out the solution 2. What we can do is what we if we sort the array. So for example, if I can show you over here, what if we sort the array, it should be 1 comma 1 comma 2 comma 3. Okay, this is a sorted array of this version. So if we after sorting try to iterate through the values of the array, we will find that the duplicate exists within the adjacent of the array. For example, in this case, 1 has a duplicate value, so its adjacent, it has its duplicate entry. So in this case, the time complexity will be O of n because we are iterating through the whole array once. But as we know, the sorting takes a little bit of time, so it will be a total of O of n log n. And regarding of space, we can consider the space to be in constant also this time, because if we can completely ignore the space required by the sorting, so it's just O of n, sorry, O of 1. So in this case, we can see that we have improved a lot from O of n square, which is a quadratic. Uh, we have just improved to O of n log n. So it's a much more improved version of our previous solution. So just to recap, we are just sorting the array first and then just iterating through the array only once, and then checking if its second or the adjacent value has a similar entry with the one that we are currently using. So let's code that up. So let's just cut these out. And then from here, let's cut it up. So at first, let's sort the area. So the area is this one, nums.sort. Then let's, like the first one, let us take the length of nums array in the n variable. So it should be and for we can just write a for loop for I in range and n minus 1, because we don't need the full length of the array, because if you can see for the last value of the sorted array, we have nothing to compare it with. For 3, we cannot compare anything with it because we don't have any adjacent values. So we are just taking up to 2, means the second last value of the array. Let's come, sorry. And then we can just write a check if nums I equals to nums I plus 1. And we can just return true. Sorry. Okay. Else we can return false. I believe this should work because let's just check what we are literally doing over here. We are checking through the array. We are just sorting it at first. So here we have sorted the array. If I can clean this up a little bit. So we have sorted the array in the 7 number line. Then in the 8 number line, we are taking the length of the length of the nums integer array in the n variable. So here 1, 2, 3, 4. The length is 4. Okay. So here I in range, for I in range n minus 1. So here the value of the range will be 1, 2, 3, and 4. So it should be 3. So the value over here is 3. If nums I equals to nums I plus 1. So we are just checking that if 1 is equals to 2, it is not. So we are just going to the next. If 1 equals to, sorry, for this one. If we were just checking that if 1 has an adjacent equal value of 1. So here 1 equals to 1. So we are just returning it to be true. Now, if we had the iteration in the middle, then we gonna have to at first, like we're gonna have to check, for example, 1 equals to 2. No, it is not. Then we're gonna have to check if 2 equals to 2. Yes, it is. Then we will be returning true. Else, if we did not find any duplicates, we're gonna just return false. Let's try to run this code. Okay, so it seems to have some problem. It's some indentation problems, maybe. Oh, sorry. I have just made this out of the function. Okay, so here the case 1, case 2, and case 3 was accepted because, as I had shown here, the results we get over here will be accepted, but and the solution is also much more improved than the previous one. The time complexity is O of n log n, and the space is O of 1. Okay, now let's move on to be the most optimal solution. Honest, there depends on what you're really trying to achieve. Um, if you can just sacrifice a little bit of space for much improved time, then you can go with the solution number 3, which I'm going to show you. But if you are gonna good with this time and just left alone the space to be in constant, then I believe that this is the most optimal solution then. But now what we are going to do is just a simple trade-off. You're gonna have to sacrifice some space for saving some time. So let me show you how we can do it. Let me just clear this off. Okay. So here what we can do is we can store the values of the array in a hash set, and then check if the current entered value exists in the hash set. So to be more precise, let me show you how we can achieve it. So suppose this is the hash set over here. And so this is the array. So what we are going to do is we're gonna check for the first value of the array if the first value exists in the hash set. So this is a brand new hash set with empty values. So 1 is not in the hash set. So if we didn't find the value, the first value in the hash set, we're just gonna simply enter the 1 over in the hash set. We store the 1 in the hash set. Now for the second case, 2. We will go check if 2 exists in the hash set. So generally, we will not be finding 2. So we will add 2 as well in the hash set. So we will iterate through each of the values in the array and check if that value exists in the hash set. If it does, we'll return true. If it does not, we will add that value to the hash set. So for the 3 number, we will add it over here because 3 is not present in the hash set. But if you notice in the 1, this is the 1. We will check if 1 exists in the hash map. Yes, it does. So we'll just return true. We don't need to add that 1 as well over here. So in this case, as hash set does not um, take up much time. So implementing a hash set will take up O of 1 time complexity. But as we are iterating through the array once, so it's gonna be O of n. Okay, O of n, time complexity gonna be O of n. And regarding of space, it's gonna be, sorry. Okay. And regarding of space, it's gonna be O of n as well, because as I mentioned, this is just a trade-off. A hash set will require some space, and the number of the space we need will gonna be the ors, or the max can be the size of the length of the array. So let's code this system up and check how this looks in the code. So let's just clean everything again. Okay, and then first let's implement a hash set. So I will just call it step first step. So this is the way we can declare a hash set in Python. Then we will start a for loop for an in nums. Nums is the integer array. We will check if n exists in the hash set. Then we will just return true. If it does not, we will just write else. We will just say HashSet. Then here we will return false. Okay. So what I'm doing here is we are just starting a hash set, just initiating a hash set, and then we are checking for n in n's, sorry, n in nums. We are iterating through each of the values of the n. I can clean this a little bit. So we are iterating through each of the values of the array. For 1, we are iterating it, and then adding and then returning it true if n is already in the hash set. So here 1 is being added here because n1 is not in the hash set, but for the last value 1 is in the hash set, so it gonna just return true. But if we didn't find the n in the hash set, for example, what happened in the first cases or the second case, 1 was not in the hash set, so we just added the 1 in the hash set. So we just added the n in the hash set. So if we did not find any duplicates, like if we did not find any value that exists in the hash set, that means then we just returned false. Let's try to run this code. Oops. Right. Once again, I misinterpreted. Oh, sorry. We need to specify the n in the hash set as well, like which value we want to add in the hash set. Here, I am trying to add the n in the hash set, so I'm just using the n in the parameters. Okay. So here, all the test cases has been accepted. So this is far more the most optimal solution you can imagine of, because here the time is O of n, space is O of n as well. Both are in both are in linear, so you don't have to like think of um, getting it in quadratic or something. It's far most the most optimal solution for this kind of problems. As I mentioned, if we need more space, like we consider the space to be more, or the space to be more safe, then we can go with the second solution, which was just sorting the array and then checking if the adjacent array has a duplicate value of it. So then we'll get a constant space, which will be O of 1. And the time will be a little bit increase of n log n, which is also a really good solution. So in this way, we can solve the problem 217. I hope this video helped even a little bit. If you already knew the solution, maybe you might have learned something new. So yeah, thank you for watching.